Hi, thanks for taking the time to consider this approach to overcoming the two limitations that plague equity oversight: the lack of statistical evidence of stock selection skill and the prevalence of closet indexing. As you know, performance data is useless in identifying managers that are likely to outperform. In fact, it's worse. Top decile managers in any one period are actually more likely to be in the bottom decile the next period than to remain in the top. But we can't really show clients managers outside of the top decile. A bigger problem is that closet indexing is the rule rather than the exception. About a third of funds and half of fund assets take too little security selection risk to overcome fees with security selection skill. Detecting and avoiding these funds is a significant contribution. But an even bigger opportunity is the fact that most, if not all, of the largest funds of funds are closet indexes, charging active fees for passive exposures. What I hadn't realized, though, is that closet indexing is an even bigger problem than hiring managers without having statistical evidence of skill. A third of active equity funds and half of fund assets take too little security selection risk to ever overcome fees with skill. Even worse than that, the traditional approach to combining active managers typically reduces aggregate security selection risk by half, which often translates to closet indexed portfolios. In fact, most, if not all, of the largest funds of funds are closet indexes, charging active fees for passive exposures. We're proposing a solution. Here's the underlying problem. For the average equity fund, idiosyncratic security selection risk, what we pay active fees for, explains only a third of the portfolio's tracking error. 2/3 is explained by passive market exposures. A market beta different than the benchmark's beta, or sector size or value betas different from those of the benchmark, typically overwhelm any contribution from stock selection skill. This is why we can't detect skill. For most active equity portfolios, more than half of incremental return is not due to the idiosyncratic performance of the particular stock selected, but to passive market exposures that are an unintended byproduct of the various betas of those stocks. And these unintentional exposures can often overwhelm any contribution from active skill. They also tend to mean revert, which is why selecting managers based on performance is such a losing bet. To detect a skill signal, we need to isolate stock selection return from market noise. And to detect and avoid closet indexing, we need to isolate stock selection risk from passive market risk. Brinson attributions attempt the former, while active share attempts the latter. While these were important steps at the time to answer the two critical oversight questions, unfortunately, they fall short because both methods assume that all stocks have market and sector betas equal to 1, when individual securities actually have very different betas. For example, Apple has a tech beta of 2.5, while IBM's is 0.2. So a 10% allocation to Apple equates to a 25% tech exposure, while the same allocation to IBM equates to a 2% exposure. It's easy to see why allocation is a bad proxy for exposure. Brinson attributions fail to predict future performance, and active share ends up missing over 80% of closet indexers. The solution is to first model individual security betas. Like the conventional Barra-type factor models, we model portfolio risk by first modeling individual security risk. But unlike the conventional models, we limit our factors to 10 independent, passively investable ETFs. And as you'll see, this makes all the difference. We estimate up to 10 betas monthly for 100,000 plus securities using a stepwise regression of residuals. Sector beta is net of market, size beta is net of both market and sector, and so on. Portfolio and index betas at any point in time are then the market value weighted average of the individual security betas. Because each of our factors are available passively, we can now accurately separate the active and passive components of both historical performance and future tracking error. For the first time, we can detect statistical evidence of skill more likely to persist and ensure we are taking sufficient active risk to overcome active fees. When security selection return is properly isolated from market noise, performance is, for the first time, predictive. We find that funds with security selection information ratios in the top decile are twice as likely to outperform over the following 3 years, and funds in the bottom decile are more than twice as likely to continue to underperform. Fidelity's Contra Fund mirrors the risk profile of the median active equity fund. Contra Fund's future tracking error will be 5%. 2/3 of that will be due to passive market exposures that are different from its benchmark. These passive risk exposures are very likely unintentional and will certainly overwhelm any contribution from security selection skill. Contra Fund is, however, taking sufficient security selection risk at 2.9% to overcome fees if they have selection skill. We can see in advance each of the passive market exposures that explain the passive component of future tracking error. Here, as typical, only 3 exposures explain over 75% of the passive component of tracking error. Contra Fund is short tech and market exposure and long the financial sector. We can also see in advance the individual security exposures that explain the stock selection component of tracking error. In this case, only 5 securities of the 275 holdings explain almost 90% of the idiosyncratic stock selection portion of future tracking error. This is not unusual, and as here, stocks not held are often the biggest contributors to tracking error. So when a search analyst interviews a manager, they will almost certainly know more about the drivers of the portfolio's future performance than the portfolio manager does. So here we are, a small firm you've not heard of, arguing for a new risk modeling approach to oversight. But one nice thing about risk models, their accuracy is easily proven in advance. Risk models, and models in general, are only valid to the extent they're predictive. The better current predictions conform to future observations, the more accurate the model. Tests show that our models are every bit as accurate as the conventional Barra-type models, which are unhelpful for oversight, but is easy to test for yourself. We're happy to provide passive replicating portfolios for your chosen funds, and you can compare predicted returns with future realized returns. Security selection information ratios in the top and bottom deciles have a strong tendency to persist. For the first time, we have compelling statistical support for selecting managers, as well as for when to replace them. But it's not enough to hire managers with security selection skill. They must also take sufficient security selection risk to overcome active fees. 1/3 of active equity funds and half of fund assets fail to take sufficient active risk to overcome fees, even with top decile security selection skill. And while it's important to avoid closet indexing funds, it's critical to avoid inadvertently closet indexing the aggregate portfolio. And that's a more common problem than we would have thought. The traditional approach to combining managers halves security selection risk, often leading to closet indexing. In fact, most, if not all, of the largest fund-to-funds are closet indexes charging active fees for passive exposures. Unintended passive exposures in the aggregate portfolio are easily offset with combinations of complementary funds or a small allocation to ETFs, which reduces tracking error while at the same time retaining or increasing security selection risk. And of course, client meetings and manager discussions are a lot more interesting. Thank you for your time. I hope you'll consider trying the models yourself. Just let me know and I'll send you login instructions.